So I want to start it off with just a little bit of review of what we did yesterday. We looked at one of our formulas for area using trig. We found the area of a triangle using the length of two known sides and the angle in between them. So that area was side A times side B times the sine of angle C divided by 2. We had several ways that could be applied. Obviously, it doesn't have to be sides A and B. It just has to be any two sides and the angle in between. So in this case here, if we are given that side B is 36 feet and that side C is 32 feet and that angle B over here is 68 degrees. In this drawing, we do not have two sides in the included angle. Remember, we need that law of cosine situation where we have two sides and the angle in between them. Not what we have here. So we need to either find this angle or this side. Well, what we can do, we can actually, the only thing we can find here right now is this angle up here, angle C. We'll set it up as 36 feet over the sine of 68 degrees. That's a side and its opposite angle is equal to side, the 32-foot side, and over the sine of its opposite angle, which would be the sine of angle C. Now we are safe here because 32 is smaller than 36, so its opposite angle has to be smaller. So we know that C is smaller than 68 degrees. Why is that important? Well, we know that C is an acute angle, so we don't have to worry about doing the supplement when we do the inverse sine. So we are going to cross multiply and divide here. My modes are set right. They are. So sine of 68 degrees times 32 divided by 36 gives us 0.8242. So the sine of C equals 0.8242. So C is the inverse sine of 0.8242. And I'm just going to do that right on my calculator without clearing it out. Second sine, second answer, to get 55.50 degrees. So angle C here is 55.50 degrees. Now I still do not have two sides in the angle in between them. But I can find angle A here rather easily by simply subtracting from 180. So I'm going to first add the two angles I have, 55.50 degrees plus 68 degrees, gives us 123.50 degrees. Then I'll subtract that from 180 degrees, giving us 56.50 degrees. So angle A here is 56.50 degrees. Now we can go ahead and find that area. The two sides are the 36 and the 32. They aren't necessarily sides A and B, but they are the two sides that we have, two adjacent sides. So 36 feet times times the sine, my angle is the angle in between them, is the 56.50 degrees. And of course, divided by 2, because it's a triangle. Giving us 480.32. And those measurements are all in feet, so this will be square feet area. So not necessarily able to just pick the information out and apply the formula. There will be times where we have to go through a process to get the information we need in order to apply that formula. The second process we looked at yesterday was if I am giving the grid coordinates for a shape. So let's say I have here -5, -2, 3, 1, 9, -1, 8, 9, 1, 7, -4, 8, and then back again. So we've got a 6-sided irregular shape there. We can find its area using those coordinates. So remember, the first step is to pick a starting point. I will pick the -5, -2 as my starting point. So I'm just going to list that here. -5, -2. And then I'm going to move around the figure counterclockwise. So I'm going to go this direction. So next is the 3, 1. Next after that is the 9, -1. The 8, 9. 1, 7. -4, 8. Then I have to close the shape. The term, if you were to do an advanced college geometry course, you'd hear the term open figure or closed figure. This is what they mean by a closed figure. We have to go back to where we started. So we have to get back to the -5, 2, or -5, -2 to close this figure so that we can find the area of it. And we can only find the area of closed figures. Now we do our diagonal multiplication. So we're going to go down, going left to right. So -5 times 1 is -5. 3 times -1 is -3. 9 times 9 is 81. 8 times 7 is 56. 1 times 8 is 8. And -4 times -2 is also positive 8. We have to add all of those up. We get 145, I believe. Now we have to go the other direction, going down from right to left. So -2 and 3 is -6. 1 times 9 is 9. -1 times 8 is -8. 9 times 1 is 9. 7 times -4 is a -28. 8 times -5 is a -40. Which I believe gives me a -64. Now remember, we have to take the bigger minus the smaller. So 145 minus the -64. Well, minus a negative is the same as plus a positive. So that adds up to 209. The area then is that number, 209 divided by 2. So the area of this shape would be 104.5 square units. Whatever units I'm using to lay out that grid would be the units of area. That was our other process yesterday, using that old surveyor's trick, well, not even a trick, just a surveyor's formula to find areas given just coordinates of vertices of the shape. Today, we want to go back a half a step, and we want to talk about regular polygons. So regular means all the sides are the same length, all the interior angles are the same size, same angle. So like a regular hexagon, at least as close as I can draw it, would look something like this. All the sides are the same length. All the interior angles are the same angle. Now, I can find those interior angles. The way I find the interior angle remember, we'll start off with the interior angle sum. That's n minus 2 times 180 degrees. So the interior angles, if I multiply that out, of course, that's 180 times n minus 360. Each angle then would be found by dividing that angle sum by the number of angles, which is just n. So 180 over 180n divided by n is just 180 minus 360 over n. So each of those angles is 180 minus 360 over n. For a six-sided figure, for a hexagon, of course, this was interior sum of 720 degrees divided by n of 6. That means each interior angle is 120 degrees. With a regular polygon, we can always divide it up into isosceles triangles. And that is done by doing the diagonals like this. Each of those 6 triangles, one triangle for each side, is identical, and they are all isosceles. So if I look at that triangle here, I'll look at the bottom one. This down here is just the length of the side of the hexagon. To find the area of that, I would need to know this length here. That length has a name in geometry. It's called an apothem. So the area of that triangle there, if I just use A for apothem, sounds like I'm speaking with a weird lisp, sorry. The area of that is the length of the side times the apothem divided by 2. So then the area of this whole figure, this is for the triangle, the area for the whole hexagon is the length of the side times the apothem divided by 2 times n, times the number of sides. There's one of those triangles for every side. So for a hexagon, n would be 6. For octagon, n would be 8, whatever our figure is. So what we want to do is we want to look for a way to define A in terms of S and N and simplify our calculation a lot here. So we've got our area is the length of our side times the number of sides over 2 times what we're trying to find is some way to define A, that apothem. So we know that each of these, oh, that's ugly. A little bit better. We know that each of these interior angles is 180 minus 360 degrees over n. Another way to look at it, another formula for that, we know this exterior angle here is 360 degrees divided by n. It's the supplement of that. Well, remember, supplementary angles have the same sign. So keep that in mind. As I draw in this triangle, to find this height, I'm going to use this length here, which is just half of my side, the side divided by 2, and I'm going to use this angle, which is half of that angle. And to find this length here, I'm going to be using a tangent. Tangent of that angle angles are 180 minus 360 over n all divided by 2 is going to equal the length of the apothem over the length of the side, of half the length of the side. Well, we need to solve that for the apothem. First thing I'm going to do is I'm going to look at what's going on inside here. If I divide this out, tangent of, I can split this up as 180 divided by 2 minus 360 divided by 2n. 180 divided by 2 is 90. 360 divided by 2n, that's just 180 divided by n. 90 minus 180 over n is the complement. So a complement would be a cotangent of 180 over n. So remember, the tangent of the angle, the tangent of 90 minus 180 over n, is the cotangent of its complement. Its complement is what we get if we subtract it from 90. Now, the cotangent is found as 1 over the tangent. So this whole angle here can be written as 1 over the tangent of 180 over n equals our apothem over the side divided by 2. Well, we're going to solve for a here by multiplying both sides by the side over 2. So this equals s times 1 is s. 2 times the tangent of 180 over n is just 2 times the tangent of 180 over n. That equals our apothem. So we go back to our original formula. The area of a regular figure equals the length of the side times the number of sides over 2 times the apothem, only we're going to replace the apothem with this formula. So it's the length of the side times the number of sides over 2 times the length of the side over 2 times the tangent of 180 over n. Well, multiplying this out and combining it, s times s is s squared times n over 2 times 2 is 4 times the tangent of 180 over n. So what this formula comes out to be, that was a lot of derivation for a formula that actually is just a little bit ugly. I'm going to rearrange it a little bit. N times the length of the side squared over 4 times tangent of 180 degrees divided by n, the number of sides. That is the area of any regular polygon. We did a formula towards the end of last semester for the area of a regular octagon. We had a formula using the length of the side, using the length of the diagonal, using the length of the flat distance. Those formulas all derive from this formula here. Well, let's apply it. First, I want to verify that it works for the simple case, a square. So let's say we have an 8-foot by 8-foot square. That is a regular polygon. It is 4 sides. So here n equals 4. and S equals 8. So this will be 4 times 8 squared over 4 times the tangent of 180 over n is still 4. Now the big key is, how do we punch this in the calculator? This one we're going to punch in the calculator in two pieces. We do this part first. So what we're going to type in is 4 times 8 squared divided by 4. It gives us 64. Then we're going to do divided by the tangent of 180 divided by 4. Well, 180 divided by 4 is 45, which gives the tangent of 1. That gives us an area of 64 square units. Those units are feet, so that's square feet. Well, we know that the area of a square, an 8 foot by 8 foot square, would be 8 by 8, which would be 64 square feet. So we get the same area using our polygon formula for that square. So that shows us that it seems to be consistent. So let's look at a regular pentagon with sides of 15 feet. So here n equals 5 because there's 5 sides, and S is 15 feet. So our formula, the area equals n of 5 times S of 15 squared over 4 times the tangent of 180 degrees over n is now 5, so it's 180 over 5. So again, I'm going to do this in two pieces. I'm going to do this part here, everything but the tangent. That's 5 times 15 squared divided by 4 gives me 281.25. Now I'm going to divide by the tangent of 180 divided by 5. Gives me 387.11. And the units used in my length is feet, so this will be feet squared. So the area of that regular pentagon is 387.11 square feet. So let's step it up to the area of a regular octagon. And that looks regular. We're going to give it a side here of 12 feet. So n equals 8 because there's 8 sides. And S, the length of our side, is 12 feet. So our formula for the area of that is n of 12 times the length of our side squared over 4 times the tangent of 180 over n, which is 8 again. Again, I'm going to do everything but the tangent first. That's 8 times 12 squared divided by 4. Gives me 288. Then I'm going to divide by the tangent of 180 divided by 8, which will give us 695.29. And once again, the length was given in feet, so that area is in square feet. So any regular polygon, we can find the area rather quickly by using this formula. Now let's work the other direction. Let's say we are working in a municipality where anything with an area larger than 200 square feet gets assessed on your taxes. So we need to keep our area under 200 square feet. And we want to build a gazebo that's a regular hexagon. We want to know what size can we make the sides. So n equals 6 here, and S is just going to be S for now. So our area equals n of 6 times S squared over 4 times the tangent of 180 over 6. Now we need to solve this for s squared. Our area is going to be 200 square feet. We're going to put that in from, get back here, from right here, our limitation of 200 square feet. So 200 equals 6 times s squared over 4 times the tangent of 180 over 6. Well, first thing I'm going to do to try to solve this for s squared is I'm going to multiply both sides by 4 times the tangent of 180 over 6. So I'm going to start with my 200 times 4 times the tangent of 180 divided by 6. Gives us 461.88. So on the left side, we have canceled out this denominator. What we're left with, what we still have there, is 6 times s squared. So I can divide by the 6. Notice I left that in my calculator so I didn't have to type it back in. Divided by 6, I get 76.98. Equals s squared, because the 6 is canceled out. Now that is s squared, so to find s, I have to take the square root. So the square root of that previous answer is going to be 8.77 feet. So the length of the side could be 8.77 feet, which would be 8 feet. Back the 8. Take that times 12, which is going to be 9 inches. Back the 9. And take that times 16. Now here's a case, because we have to stay under a certain area, we need the length of our side to be the same or less than what we calculated. So even though that is 4.5 sixteenths, normally we would round that up to 5 sixteenths. Since we have to stay smaller, we're going to round it down, even though it would normally round up, to 4 sixteenths or 1/4 of an inch. So to keep that hexagon gazebo under that size limitation of 200 square feet, we will make the sides 8 foot 9 and 1/4 inches. And that will keep us just under that 200 square feet. So we can rearrange our formula where area equals n times s squared over 4 times the tangent of 180 over n. We can rearrange that for s. It's going to be our area times 4 times the tangent of 180 over n, all divided by n, and then square rooted. Gives us the length of our side. So if we know the area that we need, and we want to find the length of a side for a regular polygon, we can use this formula to work backwards. Anybody have any questions? Okay, so we're at that point in the course where I normally would be giving you a lot of work time in class, partly so that you could work with partners or groups within the class. So since we're not in class, I'm still going to give you that time to work. I don't want to load you down with another topic today. So there's a worksheet posted in Blackboard. There's actually 2 of them. There is one on this topic, and then there's a review worksheet going over the 2 topics we did yesterday. I did posted them in the wrong order. The second worksheet that I posted for yesterday was actually the one for this topic, and the second worksheet I posted today is actually the one for the surveyor's formula that we did yesterday, or we did on Tuesday. But you should be able to keep those straight out there. So we have those formulas. There's a worksheet out there for that area of a triangle being AB Sinus C over 2. There's a worksheet out there for this formula from today, and there's a worksheet out there for that surveyor's formula for finding area. And then there's a review worksheet that has all of them on it. If you get those done, for Monday, there will be a quiz on Monday, but it won't be assigned until Monday. But if you would like, I will get that posted out there so that you can work ahead. I'll have that posted out there for you by the end of the day. So with that, I will give you guys the rest of our time here to work on it. We've got about 40 minutes left, so I'll give you that time to work on those worksheets.